In order to take a nice detailed look about where electrons are in an atom, we need to know how they fill up. Where do the lower electrons go? Where do the outer electrons go? If you have 50 electrons, in what order do they fill up? It's important particularly because it's those outer shell electrons that matter the most. So this is known as Aufbau order, German for build-up. And the periodic table is based on the Aufbau principle. We're going to show you how these electrons fill up in a very predictable order. So predictable that we would easily be able to predict where the electrons are in an element that has yet to be discovered. This is Screencast 5.2. Okay, the Aufbau order is a powerful tool. Above here we see the general Aufbau order for electrons. If you saw Screencast 5.1, you'd see how this weird pattern came to be. I'm going to just go back to it. Whoa. Not there. Here it is. Do you remember this? This was in Screencast 5.1 where we had you write down all those weird numbers, did the next row, nice, and then we found if you read this like a book, this is what you end up with. Check this out. Read it like a book. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and it can go on and on and on. As long as you draw something like this, you can do it. Why does this matter? This is really where electrons are for every element in the universe, and the ones that are yet to be discovered or the ones that are yet to be made by man. That's the little pattern we came up with here. And here's a typical periodic table. You may not have learned this, you probably didn't, but notice how it follows this order. Watch. 1s2. There it is. 1s. See this little 1s? That means the first shell, S-shaped, spherical shaped. 1s1, 1s2. We're now in the second shell. It's still spherical up to here, 2s1, 2s2. And then it begins with this 2p, meaning the electrons in this part of the second shell start to have a different shape. A P-shaped, a dumbbell-shaped, 2p6. Notice how most periodic tables don't throw in these two s's and these two p's, and they certainly don't put a little space and put in these. This is because this is a much better periodic table. Who made it? I did. Yay. Okay, so 2p6. We then go to 3s2, right there. Then 3p6. So this isn't just some random pattern. It seems to be all about where the electrons are. I moved this a little bit so you can still see the 3D right there. So 4s1, 4s2. Now let's start the 3D. Notice how we go down into the third shell. Do you remember earlier I mentioned that the electrons start to fill out of order? They fill up 2 in the fourth shell and they go down to the third shell once they get to scandium. 3d10, and it continues exactly in the order that you see for the Aufbau order. 6s2 is right here. Okay, 6s2. Now notice that there's a little line here. This is something the periodic table did just to kind of scrunch it together. We're going from, looks like 60, what does that say? 65, 66, 55, 56. Okay, and then it goes 57. Really, they should throw them all in there. They just did this to try to make everything look better. But this entire 14 column segment here should be right there. So don't forget to go from 6s2 down to, that's right, where is it? 4f14. It drops down 2 shells. I hope you're imagining the electrons filling up and going down a couple of shells and then filling up that inner shell. Unusual, yeah? Then work your way up to the next number, which is lutetium, and you end up with 5d10, 6p6. Check it out here, 7s2. Whoa, whoa, whoa. Don't go to lawrencium. Go down to actinium here, and you'll be going in the right order. And it all works out. I'll stop here at 6d10. But this strange pattern, which is actually mathematically infinite, is how the electrons are arranged. And it's important enough that they've arranged the periodic table to show this. So our conclusion is the periodic table is based on this pattern. How important is it? What can we do with it? Well, clearly it's a basis. You see these periodic tables everywhere. It must be important. Where did it come from? How did it come to be? What does it mean? All will be revealed in the next screencast. This is Screencast 5.2.